Good evening.
Hello. Okay, just wait for 2 minutes. Okay. Hi everyone. So let's start with week 10. I think we have completed certain things in the previous session, right? Like around half of the slides are completed, and I think some are like yet to be completed. We'll finish that first, and let's see the week 10 questions later on. Is that fine? Is that okay?
Yes, sir.
Okay. So can you tell me one thing? Have you watched the lectures?
Yes, sir.
Have
Yes, sir.
all of you have completed the lectures?
Yes.
Okay. Okay.
Yes.
Got it. So now I think we have left with this part. Think okay. I'll share my screen and we'll start from there. Then we'll see some questions. I hope my screen is visible to all of you. I think we have completed till here. Uh, what have you learned till now? Per, we started with the three assumptions of perceptron. What are the three assumptions in perceptron we take to show the convergence? Can you summarize? Any one of you, can you tell me what are the three assumptions are there which we use to show the convergence of perceptron? My voice is
Linearly
clear to all of you, right?
separable.
Yeah.
Hello.
Yes, yes. My
Yes.
voice is fine, right?
Voice
Is
is
the, is the
clear, sir.
voice is clear, right? Okay. Can anybody tell me what are the three assumptions?
Linear separability and the constraint. W transpose extend y greater than or equal to 1.
Your voice is low. First
Radius
is,
assumption,
yeah. One is
then gamma
linear
margin.
separability. Yeah, linear separability with
Gamma
gamma
margin.
margin. Yes.
Gamma margin.
Second is radius
Radius
assumption.
assumption.
Yeah.
Hmm.
What is that radius assumption? Says whatever the data points we are having, they
Covering the
should
All
be
further
will lie under a
longest
circle with
distance,
radius capital R.
longest distant point from the origin.
should be less than r square, right? So there it's a circular assumption. These two are there, and what else is there? I think these two, like along with this, right? This was the,
Length of W is
Lo-
equals to 1.
yeah, norm of, yeah, v equal to
W or W star.
whatever. Like basically,
W
we will
star
put
is a
that.
particular direction we
Yeah,
can
W
choosing
star is the
anyhow.
optimal solution. Huh?
Yes, optimal
W
solution.
star is the optimal solution, and W is what? Like we are saying that whatever W we are searching, right? Whatever the space of W we are searching, the length of that space should be equal to 1, right? That these were the three assumptions which we have started, and then we see that the uh, convergence of perceptron algorithm. But what do you mean by convergence of perceptron algorithm? That is the number of mistakes, right, are finite.
Number of mistakes is less than or equal to.
R
Or
square by gamma
finite
square.
or
It
as
has an
minimum
upper
as
limit.
possible.
Has an upper limit.
Yeah. So these are number of mistakes are upper bounded by. So this is the upper bound, and they are upper bounded by this quantity, which is r square by gamma square, right? And if what does that mean? It will always, the number of mistakes will always be r square by gamma square, or they can be lesser than that.
Lesser also.
Lesser than
Lesser.
that. But why we are saying it is converged? Because the number of mistakes, since r square is the whatever the data points we are having, it is the maximum radius we are taking, right? Maximum, and gamma is the that also we have seen that why gamma has to be bounded and how it is getting bounded. So by r square by gamma square, that means it will, this number will be some finite number, and if this is the finite number, that means the algorithm will converge within certain finite limits. But that does not mean that it will always be converged with r square by gamma square. So let's say r square is, let's say, 10 and gamma square is, let's say, 2. Then that means what? The number of mistakes are 5. But this is always, the algorithm will converge always by amount of 5, or or the number of mistakes will always be 5 or less than that. It is possible to converge the algorithm by, let's say, within 3, the number of mistakes will be 3 or 4. That is possible, right? Is that correct? Do you
Possible,
understand?
possible,
Yeah.
possible.
So yes. So this is the upper bound. That does not mean that it will always be converged with this value. It can be lesser than that. But how we are saying that it will be lesser than this? So why it is changing always? Any idea about it? So sometimes algorithm may converge in, let's say, three iterations, maybe 4 iterations, or maybe 5. With r is r square equal to 5 and gamma square equal to 2. Sorry, 10 and 2, right? So it is possible that sometimes the number of mistakes we made will be 3, sometimes it will be 4, sometimes it will be 5. What does that mean? This is sensitive to something, right? Some quantity. What quantity it is sensitive to?
W is not fixed all the time. That there can be change, right?
Yes. So how initialization of W, right? If you remember what is perceptron algorithm, so what you do in perceptron algorithm, you first randomly. It's not always 0 0. It can be like you can select W randomly, right? So W naught is selected randomly, correct? So whatever W are choosing. So let's say if you randomly choose 0 0, it will give me different path, because let's say Wt plus 1 will be equal to Wt plus xi yi. This is if mistake. Otherwise, Wt plus 1 equal to Wt only, right?
WT.
So sorry, Wt. So let's say if I initialize W naught with 0 0, it will yield. It might yield a different solution. If let's say W naught is equal to, sorry, W naught is equal to, let's say, 1 1 or some other quantity, right? So how you are actually choosing my W, right? Since it is randomly we are selecting, it can start with anything, and if you start with whatever W, this algorithm will give you different solutions. Is that correct? The only thing which is guaranteed is that it will converge, right? It will converge, and the number of mistakes will be upper bounded by this. So that means it cannot go beyond. So for this particular values, it cannot go beyond 5, right? So you whatever W you choose, the number of mistakes never be 6, or it may never be 7, or like that. You understand the point? The maximum number of mistakes can do is 5 in this case, in this particular example. Is that okay? I hope it is clear.
Yes,
So
sir.
basically, gamma equal to 2 is the optimum gamma, right?
Yeah, you can say that. Yes. Right. So this was like the like cooked up example. This may not be the true one, but I hope you understand the point in that.
Mm.
It depends on, basically it depends on gamma, right? The margin, whatever the maximum margin we are selecting it, because I think when we have started this primer and dual solution, I think somewhere I've mentioned about the, okay, the width of the gamma, right? I think somewhere it was there. Let me show you this. Yeah. So this was what we said in this uh, derivation, is that I hope this was fine, right? We have started with this primal objective, minimize over W f of W and such that G of W is less than or equal to 0. Okay. Width of the W is, width of W is basically what it is, 2 gamma, right?
Yes,
You
2
remember
gamma.
this part? 2 gamma is equal to 2 by length of W square. That
Omega
means
W square.
gamma depends on W, correct? Gamma depends on W. Is that fine?
Sir, but I didn't understand how can we take how did we take gamma equal to 1? Like we are telling such that W transpose Xi Yi greater than equal to 1.
Here, right? Okay.
Yes.
You're just normalizing. This
Yeah,
is not the actual W. If we
correct.
divide with norm of W, then we'll get
So this was the
like
problem,
one
right?
more numbers.
We were here, right? Here, if you remember, okay, I hope you remember this part. Maybe I'll start with this and then we'll. So this was the part, right? What was our objective here? This is my objective function.
Maximize gamma, the margin.
Yeah, maximizing the gamma, and such that what is the so for that maximization of gamma, these are the parameters, right? W and gamma, correct? And such that what are the constants? These are constants, right? We put these constants. What is this constant? For any
That's constant
I,
for
yeah, this is for particular data point, right? So for
all
any
the
data point, yeah, for all data point, let's say W transpose Xi Yi should be greater than or equal to gamma. Is that correct? So what does that mean? Geometrically, how does we can say that? Or let's say if this was my W, this is my like separating hyperplane, and let's say this is gamma, right? Gamma, we are taking both sides the same, right? This gamma. Now, what does this statement says? Any data point we are selecting here, right? Let's say the positive one or the negative one, they shouldn't be here, correct? Like that. Is it correct? Either
yes, sir.
they can be on the supporting hyperplanes.
Yes.
Where are the supporting
Can't be in
hyperplanes?
between.
This is the supporting hyperplane. They can be on this hyperplane, or they should be
Border.
away from that, right? This is what greater than or equal to gamma means, right? I hope it is clear. And one more thing we have said that it is W shouldn't be any arbitrary W. It has to be, its length has to be equal to 1, right? So that means we are restricting W also in this. Is that correct? Is that fine? Okay.
So your voice is breaking.
Okay. Is it okay now?
I could hear you clearly
Is it
earlier,
better?
but now only it is breaking. This time it is okay.
Is it okay, right? Is better?
No.
No? Still it is breaking?
Yes,
Breaks
sir.
in between, sometimes in between.
Okay. I don't know. Maybe network issue is there, but
Yes, sir. It's
let
better
me
now.
better, right? Okay. Okay. Let me know if it is breaking a lot, then I'll switch the position maybe. Okay. Okay. So right now this is clear. Till this part is fine, right? And what we are saying is gamma is a function of W, right? So if my W is constrained by equal to 1, that means the length of the W is equal to 1. Can I or can I maybe change these constraints or the gamma constraints, right? Whatever we are selected, this constraint, can we merge these two constraints together? So this is constraint number 1 and this is constraint number 2. So this is inequality constraint, this is inequality constraint, and this is what your equality constraint. I know that gamma is a function of W. So we have two different constraints, but is there any possibility that I can maybe you know merge these two conditions and make it one as one? And if it is possible, how can we do that, right? So that is what I think. I have skipped that part previously, but it is just a normalization thing. Maybe I'll just take it over here. Okay, so I'll just draw a diagram. Let's say uh, this W1. Let's say this is your W. Okay. So for W1, which is the supporting hyperplane, oh sorry, separating hyperplane, this one, right? Okay, what is the equation of this line or hyperplane? Is W1
W
transpose
transpose
W1
X
transpose X
0.
equal to 0. Okay. For this W2, this is the hyperplane,
Y
Y
axis.
axis.
right? And the equation of this is W2 transpose X equal to 0. It says the supporting hyperplane is this one. Let's say will the margin for this two be same or it will be different?
It can be different.
Yeah, it is different, right?
But width can be same.
No, no. Yeah, mostly, but why it is different and why it is not? Like why we can say that it is different or not? Like, based on what? Based on the fact that gamma depends on W, right?
W.
So that is what, like, gamma is a function of W. We know that, and that is the case. So if my this W1 is different than this W2, sorry, W1 is different than W2, definitely it will have the different gammas. But let's say if I kept my W1 and W2 into a unit vector, right? What we are saying that whatever vector space of W we are seeking, it has to be equal to, like, it should be within the circular region, right? Is it fine? This is okay, right? So let's say then my W1 will be this. So this is, let's say, W1 prime, which is, I can say that it is effective W1, and this is W2 prime, which is effective W2 for the for this particular case. And accordingly my margins will change, right? Okay. So suppose, what is this line? What is the equation of this line then? This is the equation of line such that all x or all the data points over this line, they will follow which equation? W1 transpose x,
W transpose Xi equal to
not
gamma
xi,
Gamma.
yeah, gamma, right? So let's suppose
gamma.
this gamma is equal to 5. Suppose, fine.
Yes.
I'm taking the same example, whatever is there in the lectures. And what will be, let's say this margin is lesser. So this the equation of this blue line is, it will be all x such that W2 transpose x equal to 3. Okay, is that okay?
Yes, sir.
But for my problem, what is my objective? I need to find out the maximum for W gamma, and such that the constraints are what? W transpose xi yi is less than or equal to 1.
So greater than.
Gamma, sorry, is equal to gamma, and what else is
So,
there?
so gamma should be the same, no?
What is it?
Gamma should be the same, no? If the gamma is the closest distance to the closest point on either side of the classifier, no? Then
No,
other
no.
side also it will be the same distance. No? We are
Yeah,
assuming.
that is okay. That is fine. See, this is okay. So gamma is, we are actually saying this is gamma, right?
Yeah,
Is
but
gamma
one
1?
side you are taking 3 and one side it is 5.
No, no, there these two different W's are there, na? This, okay. This is gamma 2, correct? And
Acha,
I'm
okay.
taking gamma 2 equal to 3. And I'm taking gamma 1 is equal to 5. So gamma 2 is for,
Yeah,
this
got
is
it,
for
got it. Sorry.
W1, right? Yeah, for W2. Is that okay?
Yeah, it's a fine.
Fine. So when I wanted, I know that this is equal to 1, right? And I just wanted to see that. But see, if I wanted to solve this problem, right? Can you think of, like, logically, can I compare this to W1 transpose x equal to 5 and W2 transpose x equal to 3? And if I ask to choose which one is the which gamma is better, so we can directly go with the 5, or we should, how can we compare these two? Is it comparable, or are they comparable, these two? They are not, right? Or this W1 and W2 are comparable for the given gamma?
What exactly? No, it will depend on the data points also.
Yeah. No, it will see data points are same, correct? The,
Okay, okay.
the vector is different, no? So
Mhm.
this gamma is basically depend on W1, right? That's a gamma 1. And this gamma 2 is depend on W2. So if I change the length of W1, let's say my length of W1 is this one. If it is more, right? What will happen to gamma here? It will also increase, right? Accordingly. So it
Yes.
may become 15, suppose, right? But what we are saying that how to compare different gammas is by what? Is by making the length of this W to a unit vector, correct? So if that is capped, then it will be easier for me to compare this to gamma. And in that, how to do that? To
Why?
yeah. So
Why?
what we do is we'll just divide it by 5 here and make it as a unit gamma right here and here. Then here, what will happen to this problem? It will become W2 transpose by 3 to x equal to 1. Is that fine? Now I can compare, right? Because here if you see that x and x are same, 1 and 1 are same. Now I can compare with this W1 to W2, right? And after comparison, I can choose that which one is the better W. Is it correct? Is that fine? See, what I said is there are different W's, and there are when you have different W's, how they are different? The directions, right? There are different directions which are like possible. So this is also W1 is also yeah, the correct W. W2 also is the correct W. Why they both are correct W's? Because they are able to separate all the data points correctly. Correct. But we have put one more extra condition that they should not be just classifying the points correctly. They should be classifying the points correctly with maximum margin. Correct.
Yeah.
In that case, if I wanted to satisfy the second condition that the margin has to be maximum, then I have to be able to compare the W1 and W2. And how the way to compare the W1 and W2 is to make both of them unit vectors, right? Or either you can make all the margins as the same, correct? If I make all the margins same, in that case, I can be able to definitely compare this W1 and W2. That was the idea here. I hope it is clear to you, right? You understand
Yes,
the
sir.
concept? Okay. So now my this problem, right? This problem I have just make it simple uh by merging these two constraint. And what is that now? Maximum W and gamma, and such that now it should be W transpose xi yi equal to not equal to greater than equal to 1. Now this is the problem I need to solve. Further, what happens is since gamma is a function of W, what I do, I will just make this problem as maximize for W, and it should be a function of W such that W transpose xi yi is greater than equal to 1. Okay. And then we saw another, I think there is, if you watch the lectures carefully, uh, there was one more thing sir has implemented, that this f of W, which is 2 gamma, it has to be equal, or it is called as a width, and width is a function of W. And what is that width come out to be? It's 2 by length of, I think, W or W square it is taken. Some books actually have taken this 2 by length of the W instead of a square, but in our lectures it is taken as this is non-standard uh, length. Okay. And now this problem has become max over W, which is 2 by W square, such that W transpose xi yi is greater than equal to 1. Now this is the problem which we need to solve. One more thing we have, yeah.
Sir,
Hmm.
so why have we taken, like, for our course, why have we taken specifically 2 by W square?
Because it will become the simpler thing, no? Like
Okay.
if
Understood in
I
terms of norm
yeah,
and right? Calculation.
calculations, yeah, because we wanted to see the derivation, no? So length
Mm.
of the square, usually it is like when I take a derivative, right? Suppose
Mhm.
the 2 and 2 will get cancelled, otherwise the 2 will remain, right?
Okay.
That was the case. Uh, that's why we have taken it. The same problem, actually, see, this is the convex condition, right? So the same problem, I think, okay,
Nice function.
yes.
Sir,
So
whose
this,
derivation we will take?
huh?
You are assumption na 2y w norm square na.
Huh.
Then, so sir, which things
I'll
we
tell
are
you.
taking?
I'll tell
Why
you.
we are?
It's okay. I'll tell you about that. Don't worry about it. So right now this is okay. Until this point is fine. Okay. This same function, the maximize over w, I can make it as minimizing functions. Why? Because this is a convex function and it is possible, then I can do this maximization problem. I can write it as minimize over w, length of w square by 2. Is that okay? Or I can write it like this, half length of w square, and such that the constants will be same. Constants are w transpose xi yi is greater than or equal to 1. Is that okay? This also is fine.
Okay, sir. Okay, understand.
Huh. So have you seen the uh, Lagrange multiplier? So that this is what my
Never have
constraint is, constraint optimization problem,
Yeah,
right?
yeah.
Okay, so this is a constraint optimization problem, and how to solve this constraint optimization problem. So to solve this problem, what I need to do is, uh,
Lagrange multiplier.
yeah, I can use the Lagrange multiplier. And what does that Lagrange multiplier do, or how can we write this Lagrange multiplier?
L
So
is cos p.
functions.
And I think, okay, one more thing. How many constants are there? Can you tell me the number of constants here? I think we have discussed it last time. Tell me once again.
One.
One
Not one.
constant.
This is for all
And
I, right?
Yeah.
Okay, okay.
Let's say I equal to, how many data points are there? 1, 2, 2, n.
And
So how many constants are there?
N constant.
and
N constants.
N constants, right? And what is W here? In how many dimensions W is?
d
If,
dimension.
yeah,
Data.
if xi is in D dimension, then W also is in D dimensions, right? Just remember all these parts. Fine.
sir, for
Yeah.
soft margin it is 2n, right?
Soft margin we have not touched it yet, right?
Oh, I'm just
Okay,
listening.
we'll discuss that time. Fine. This we are actually in the hard margin swim part only. Fine. So okay. So what is the next step to do this is to write the Lagrange function, right? And Lagrange function is it is a function of W and alpha. So W is in RD. Alpha will be
Alright.
Rn, right? Yes. So alpha will be like alpha 1, alpha 2 to alpha n, because we have n such constants. How will I write this one? Half. So objective function, this is f of w, right? Objective function plus,
Alpha or constraint.
so summation of I
Summation
equal to
of
1 to n alpha
One
I.
five
So this is greater than or
one
equal to constraint.
minus
So how will I write greater than or equal to constraints? So
One
I need to make this as less
less
than or
than
equal to, right?
1 minus
Uh,
W transpose XL.
yeah. So it will be 1 minus W transpose Xi. Okay.
into y.
Is that okay? This fine?
Yes, sir.
Good. Okay. I think till this part is fine. Now I will just
Sir,
rub it here. Yeah.
sir,
Yes.
sorry to ask,
Yeah.
but I still didn't understand how by dividing the right side by margin, why are we getting still W transpose Xi in the left side?
Oh, this is not W actually. I should say that this is W prime. This is like W. Okay. We are taking W, but it should be W prime equal to W by gamma. Is it okay?
Okay.
So
And
this
in
is not
the
W. This is W prime. But see,
okay,
if I write like all the W primes everywhere, what will happen? It will be like it will look bad, right? That's why it is since it is W transpose, I'm just writing the W, but this is not W. This is effective W. I'll say that this is effective W.
okay.
Okay,
So we are minimizing this W prime in the formula.
correct. Because when I take this one here, right, it should be understood that W has to be W by that gamma, that particular gamma. Correct. Because for every W it will be different, right? So suppose my W1 is 5. Sorry, W1 is some, let's say, oh yeah, some vector, let's say 10. Gamma is 5. W2 is another vector with, let's say I'm taking the length and length 5, gamma 2 equal to 2, W3, the length is, let's say, 7, gamma 3 equal to, I don't know, maybe 3. So then what we are taking is, we are not taking this separately, we are taking W1 effective, right? So I'll say effective is equal to length of W1 divided by gamma 1. W2 effective equal to length of W2 by gamma 2. W3 equals to length of W3 by gamma 3. So this will be actually become 2 because it is 10 by 5. Okay, I'll write 10 by 5. Here it should be 5 by 2. Here it should be 7 by 3. So this is going to be 2. This is going to be 2.5. This is going to be 2.3, right? So which one should I select for my problem?
Minimum
W1,
one.
Maximum one, right?
maximum margin one. So W1.
W2, this maximum margin, right?
Yes, sir.
Okay, yes.
Is it correct? Because see, my problem now become what? W1 effective transpose, sorry, W1 effective transpose X equal to 1. Here transpose X equal to 2. W3 transpose or effective transpose equal to, sorry, not 2, 1, 1. So all my right hand side is same, right? All my data points are same. Then which one I should pick here? Which W2 I should pick? This one, right?
Sir, but for first one, gamma 1
Hmm.
is 5. We have to select the maximum margin, right?
See, if that was the case, then I shouldn't be doing this thing, right? Why we are doing this effective W? Why we are taking effective W to compare, right?
Correct.
This looks, see, if I, that's what I told you, right? See, there is this W1 is equal to 10, and then uh, this gamma is accordingly is equal to gamma 1 equal to 5. So if I go and take this W1 as, let's say, 20, what will happen to gamma? Gamma also will change, right? Maybe to 10. That correct? So if I just
Correct.
increase it here, the gamma will be changing. Then which one I should choose, right? That is the case, and we wanted to compare, right? So whenever you wanted to compare, you cannot compare different quantities, correct? So let's say I'll say that I have 10 kg weight and I have maybe 20, no, let's say 15 pounds weight. Which one is the larger weight? Let's say
10
which one
kg.
will it be? Okay,
Sir,
Pounds, right?
huh? This is pounds, 15
This is
pounds and
no,
kg.
15 pounds is the lighter weight. 10 kg is heavier.
But then you will say that let's say if I do not have the understanding of the units, I'm going to select 15, right? As a
Uh-huh.
heavier one, correct?
Yes. Yes.
So these two units are different. Then how should I compare these two weights? I will either make both of them into kgs, or either I will make them into
Conversion,
pounds.
conversion.
Yeah. So if I convert it, this will become 10 kg. This will become 7.5 kg. Now which one is the? So I'm not going here with the numbers, right? I'm going with the same units, right? Correct. I need to
So,
convert, and that is
so,
what we are doing in here.
so in this one, but because we are finding the prime, right, basically for the
Hmm.
respective W's.
Correct.
So
Correct.
this, because we have to bring it to W transpose Xi y greater than equal to 1, right? To a
Hmm.
same this thing. So
Hmm.
in this thing, sir, shouldn't we go with the one which has the highest gamma?
Yeah, but geometrically it is 2 by norm of W, right? So if the norm of W decreases, then gamma will decrease. Like, this is the geometrical idea, right? The gamma
Correct. Right.
is
Ah.
just algebraic thing, but the actual geometric margin is like 2 by norm of W. So when the norm of W decreases, no, the actual margin increases.
Gamma is a function of W,
Okay,
and how
okay.
it is related?
Gamma is 1 by W square.
Ah.
2 by W
Correct.
square.
Right. Or 2 by W square or whatever. So
Inversely
if
proportional.
yeah, if my W increases, gamma will decrease, right?
Okay,
Is
we
it
want
correct?
to increase gamma, right? Okay, higher, the
Correct. This
best
is
possible gamma.
yeah. Then it has to be
So
the
W
lowest
higher.
W.
W should decrease.
W should be lowest one, right? If you look at this one again, this is the one, right? Correct. Is it
But
okay?
sir, in
Ah.
this one, fine. This is okay. I got it.
Hmm.
But then, like, we calculated this W prime, right, sir?
Ah.
Then after that, like, we are going with 2.5.
Yes.
This part I didn't get actually.
Here, why I'm going with this? Huh?
Yes, yes, yes.
Because for maximum margin, right? So okay. So let's say okay, I should be telling you. Okay, let's maybe I'll come back to that part again. So till now, if you understand this relation, right?
Yeah, yeah,
Right.
this is
This is okay. Geometrical also is fine. So that
yes.
means I should be selecting that W, which
Mhm.
gives me the maximum
Highest,
margin. This is okay. Yeah.
highest
We
gamma,
will
yes, yes.
we'll look into this numbers later on again. Whenever we'll complete our solution, right? I'll again maybe come back to this part. Okay. So Lagrangian. Okay, we are here, right, with the Lagrangian. What is this Lagrangian function? This is okay. Till now, this is fine. We are taking all the
Yes,
effective
yes.
W. Hmm? We are
Yes.
taking effective W. There is no, when I say this equal to 1, it has to be effective W. I hope till this is okay. Uh, okay, then how to solve this problem then? This problem is how to solve this problem. I need to make the dual, right? Or,
Yeah.
or okay, what will be the primal problem? Let's say. Okay, we'll talk about the dual problem later. What will be the primal problem now? This is what I need to solve, right? This is the problem which I need to solve. For that, I did use the Lagrangian function. And now what I need to do here. Now, how many variables are there? Okay, let's discuss about that first. How many variables we are having? W and alpha,
Alpha.
right? So W is a vector, alpha is also a vector. W is d-dimensional vector, alpha is n-dimensional vector. So these two variables I'm having. Now, first of all, I need to do what? I need to uh, so
Construct the
my
prime.
overall objective is to minimize this quantity. Is that correct?
Yes.
But here, to do that, I need to first maximize alpha, right?
Yes.
And alpha has to be greater than or equal to 0. Do you agree with that part?
Hmm.
Okay. So then it has to be Lagrangian this. And overall problem is to solve, minimize W, right? Is okay? Is that okay?
Yes, sir. Yeah.
Okay. And that means if I write it again, it has to be alpha is greater than or equal to 0. What is the Lagrangian function here? length of W square plus summation of I equal to 1 to n 1 minus W transpose psi by I. Alright, sorry, and 5 and it's minimizing, right? And this is what my primal problem is. This is what it is called as a primal problem. Solving this problem is maybe a little bit difficult one. So we need to, there is one more idea to solve this problem is what? By using the dual problem. Okay. And this equivalent uh, to this part, which is maximum over alpha is greater than equal to 0 and minimize over W half alpha I 1 minus W transpose xi yi. Right. Okay. This is the same problem I have written. Only what I have changed here, the
Positions.
constant. Yeah.
Min max.
Yeah. Min max will become max min. And this is your dual problem, right? One more thing to note here. We have done here min max problem to max min problem very easily. The reason behind this is what?
Convex
Whatever.
function.
Yeah, whatever this function is there, it's a convex function. How we can prove that? Is this a convex function?
Yes.
Yes. Is this a convex function? This is a linear function,
Yes.
right?
Linear
This
function.
linear one. This linear function. This is the quadratic function.
Quadratic.
And both linear and quadratic are convex functions. And we know, I think those who have studied MLF, I think those who are currently studying MLF also, I think this week has been completed. So when both of the functions are convex and we wanted to take a sum, the sum of the convex functions is convex, right? And if the function, right? So if the function inside this conditions, if it is convex, then I can do I can interchange the what do you say, the constraints, or the min max has to be, it can be exchanged, right? So it can become max min easily. If it is not, then we should be, and it is also possible there as well, but it is not that straightforward whatever we have done in here. So instead of solving the primal problem, what we are trying to solve is now trying to solve the dual problem. Okay. So let's say there are two parts for this problem, which is this one part. Okay, I'll just write down this. This is one part and this is another part, right? These two parts. What does that mean? Either I should do, so first of all, what I'll do is I'll solve for this minimization problem. I'll solve for minimization and then I'll do the maximization. So there will be different choices of alpha. Do you agree with that part? Correct?
Yes.
It can be
Yes.
like several alphas, and we are going to pick that alpha which maximizes or that maximizes this function. Let us call this function as f1. Let's say f1 of w, and then what we are trying to do here is we are maximizing alpha greater than 0 for f1 of w. Okay. Now, and let's say this is your f2 of w. Is that okay? Is that fine? What do you understand by this statement? We wanted to maximize this function for and I will pick only that alpha which gives me the maximum value for this function. So that means I will have a choice of different alphas, maybe alpha 1, alpha 2, and all of them are in Rn. Okay. 3. And I'll be picking that one which gives me the maximum. And suppose this alpha 2 gives me maximum, then I'll say that the answer to this problem, the maximization problem, it is alpha 2. So in general, how can we do that? Let's fix some alpha. Let us fix some alpha, and for every alpha, which problem we are trying to solve? Minimize over W half square plus summation of I equal to 1 to n alpha I 1 minus W transpose xi. Okay, is that okay? All right. So for particular alpha, we are going to solve this, and how to solve this? There is one way, which is what? Uh, Calculus, right? By the calculus, how we do that? How we solve the minimization problem? We differentiate this function. Let's say this is
Yes,
f1 of w. We differentiate this f1 of df1 w by w and put it to 0. This is what my solution is. And tell me, what is the differentiation of this quantity? Is
Uh,
2 get cancelled, right?
Yes.
W
W.
plus
W, let's say W alpha. Why I'm saying W alpha star here?
optimal by alpha.
Optimal.
Yeah, but it is optimal solution for this particular alpha.
Alpha.
So it is not like uh, entire solution, right? The entire solution will when you will get when you solve this problem also, right? Is that okay? So we'll get like different values of W's, but that will not be the same. So for example, let's say for alpha in 1 equal to 5, W alpha 1 is equal to 3. For alpha 2 equal to, or W alpha 2 equal to 5, it is equal to, let's say, 7. Or I can okay, maybe W3, and F of okay, what you can do here is, can I say that, okay, F1. Six. Okay, which one I should pick now? Which will be the solution for alpha? Alpha star will be equal to alpha 1, alpha 2, or alpha 3?
alpha 2.
Alpha 2, right? Because the function here is
Maximum.
maximum. So that's why we'll pick alpha 2 as the solution. And this is the solution for primal problem or dual problem? Dual problem, right? Correct. So this is what we are trying to solve. I hope you understand this part. Then that means whatever solution and this alpha we are getting for particular or W star we are getting for particular alpha, that is equal to, so the differentiation of this will be W alpha star plus here. What is the differentiation here? Minus,
Summation over I is equal to 1 to n.
okay, summation of I equal to 1 to n,
Alpha into minus xi.
Minus X.
right? And that is equal to 0. So can I say that it is minus? And then what is W alpha star is equal to? It is equal to summation of I equal to 1 to n alpha I xi yi. Is that okay?
Yes, sir.
This is what we are getting. And what we can understand from here is, what is xi yi? It's basically it is a data point, right? Xi yi is particular data point, right? Because your xi is in RD, yi is in plus minus 1, correct?
Plus minus.
Whether it is a positive, and what is alpha I star is always greater than or equal to 0,
Zero.
right? So can it be looked as the linear combination of W alpha star is a linear combination of data points? Can I say that?
Yes.
Because alphas are some scalars, right? This is a scalar quantity, and I can see that um, alpha I'll get if I have 10 data points, I will have certain alphas for that, and alpha will be like it is a vector, right? In like in let's say 10 dimensions. I'm just taking the sum of that, right? If I take the sum of all data points with this, so I can consider this as a weight, right? Kind of a weight, right? Because it is a weighted sum. It is a weighted sum of all data points, and this is possible for particular alpha. So for different alphas, we can calculate this W alpha star. And but my objective is not to find W alpha star. What is my objective here? To find alpha star, right? Correct. All of you agree with that?
Yes.
Yeah. And now W alpha star. I think previous week also we have discussed the W alpha star. I can write in this is what like this algebraic form. How can I write this in vector form?
XY alpha.
I'll not tell what is XY alpha now. We're just because I think I have already said this. What you do next is this is
Put the star.
solution for fixed alpha, right? Fixed alpha. Now I wanted to find alpha star. What I where to substitute this to this equation, right? This dual equation. And if I substitute that into the dual equation, where I'll substitute here, so the point this here, I substitute here and here. And if I substitute that, you can substitute it later. I will just write the simplified form, and that is equal to alpha transpose 1 minus half xy alpha transpose and xy alpha. Okay. Any problems here? Anything? Any issues?
So
No,
you
right?
upload this PDF on the dashboard, right?
You wanted this? Okay, I'll upload this. Fine. Is that okay? Now, can I write one more time the primal and dual? What is the primal problem? Then tell me what is the problem? Half. Sorry, minimize.
Minimize W and alpha.
This is your uh, W for such that W transpose xi
X, Y, yi greater than equal to 1.
1, and dual problem is maximize
Alpha
and for
Alpha.
this quantity, right?
minus half of XY alpha transpose.
So can you just multiply this again? And if I multiply this, what will this become? Alpha transpose y transpose
X
x transpose
transpose XY
xy alpha,
alpha.
right? If I write this as an alpha transpose y transpose x transpose x, y, and alpha, right? This is what my dual problem is. Okay, so these two problems we are having now. Why we are doing this? Can you tell me? Why I should not solve this primary problem, and why should I solve the dual problem? The thing is, this can be kernelized, correct?
That is, that is
Kernel.
covariance kind of mean centered data. Oh
Correct.
no, sorry.
Yeah,
It's
covariance type of matrix. This is covariance type of matrix, and if it is covariance type of matrix, then that means it can be kernelized. And
Realized.
one more thing is the dimension of this is n cross n, right?
10%.
So
correct.
if my d is greater than n, much greater than n, right? Because your w is in rd and your alpha is in rn, right? So when my d is much greater than n, then solving this problem will be a good idea, right? We have seen it like multiple times while whether it was a principal component analysis or it was a linear regression analysis. Uh, that's what again it is possible. Another thing is there is one more point I think sir has mentioned, which is dual constraints are easier. Okay, because here in primal, what problem we are trying to solve is min max, right? And in dual, which problem we are trying to solve? Max min, right? If you can see it here, in dual case, it was a max min problem, and in the primal case, this was my primal case. The primal case, it was min max problem. Solving actually sometimes solving min max problem is a little bit difficult than solving max min problem. Fine. I hope this is fine for all of you. Okay. One more thing is now I know that W star. What is W star here? W alpha star is summation of I equal to 1 to n alpha I star xi yi. We said that this is what your data point is. So that and alpha should be what? Is greater than equal to 0, right? Correct?
Right.
And so that means where are these important points? These are the important points, right? Where alpha is greater than equal to 0. Correct? For alpha I star. Let's see if it is alpha star. Fine. So this is what my optimal solution. We need to say that where these points lying. Okay, good. One more time I'll write the primal solution. What is my or primal problem? What is my primal problem? Can you tell me once again? It is min max problem, min over
W.
W
W. Then max
max
over
over
alpha greater than
gamma
0, alpha greater
alpha.
than 0, right? And let's say it was f of w. There is a function of w. What was that? Half length of w square plus alpha
Alpha
into the constraint, right?
G
G of
of
w, right? And the dual problem is
mean of
max
max alpha
max of alpha is greater than 0,
in
min
W.
of
N of W
w f of w plus alpha
Alpha G of W.
G of w. Is that okay? Okay. And what was the solution for what was my primal solution? W star, right? Let's say W star because uh, the solution, the final solution is dependent on this, right? So W star is the primal solution. And what is dual solution? Alpha star is a dual solution, right? Okay. So if I substitute W star into this, okay, what will be the equation? Max over alpha greater than equal to 0. What will be the and here it will be f of W star plus
Alpha G of
alpha
W star.
G of W star. And I think okay, I think I have not touched to the one part. But what is the solution for I think those who have watched the lectures, they might appreciate this part. What is the what is this solution for? Like f of W star plus alpha G of W star. What will be since G of W star is what? What kind of constant it is? Is this constant, right? This is not equal to constant, right? Is okay?
Yes.
What was that? 1 minus W transpose xi yi is less than or equal to 0. And that's why we have taken that alpha I into this part, right? So G of W star is a less than or equal to 0. In that case, what will be the which value it will, because since it will be a negative constraint, so the maximum of this function will
Zero
be
is
what?
the maximum. Zero.
No, no, f of W star, right?
Yeah. if we take 0 as J of W star.
Yeah, alpha will be then 0. Alpha will be equal to 0, and then our object, the value of objective function will be f of W star, correct? Here alpha, for alpha
Yes.
equal to 0, it will be alpha star, or alpha equal to 0. This is the objective function value I'll get. And alpha star is a primal dual solution. And if I put it into this, what will happen then in this problem side? It will become min over W f of W plus
Alpha star.
alpha star G of W, right? Okay. So now this, at this point, min of W, it can be W star, right? Or it can be something else. But let's say if W star is, if I wanted to find minimum of W for this function by substituting the W star, what will be the value of this function? Okay, one more thing. Okay, one more thing before going there. F of W star should be equal to what? Can it be equal to this? Because at least we should know that the primal solution should be equal to dual solution, right? Is
Yes.
that okay? In that case, that means f of W star, it should be equal to min of W, f of W plus alpha star of G of W. Is that okay? This equality has to be whole, correct? But if I put W star here in the right hand side, what will be the value of this function? Will that be equal to f of W star, or will that be less than or equal to, or greater than or equal to? You understand the question?
So can you repeat, sir?
So if we, so here, if here, write this equation as min of W, f of W star plus alpha star of G of W star. If I do that, will this quantity be equal to f of W star, or greater than or equal to f of W star, or less than or equal to f of W star? Think about it.
Should it be equals?
So it depends on G of W. No? If that is less than or equal to 0, there should be
No,
f
G
of
of W,
W
G
star.
of W is less than or equal to 0. I'm telling you that G of
Okay.
W star is,
Then it is f of W star
then it should be equal to, or greater than or equal to, or less than or equal to.
equal to.
It will not be equal to, right? Equal to is possible only in this case, right? The primal solution. I have taken alpha star also, right? I need to maximize this, and after maximizing, I have taken this as alpha star. Alpha star may not be equal to 0, right? It may not be equal to 0, right? It should be greater than or equal to 0, right? This quantity comes when if alpha is equal to 0, right? Is that okay? This fine, right?
Yes, yes.
So in that case, if alpha is greater than or equal to 0, then in that case, it should be less than or equal to 0, right? Or
Yeah,
sorry,
it will be reverse. It
less
will
than
be
or
reverse.
equal to f of W star, right?
Plus alpha star. Okay.
Now you are able to understand this part. If alpha star, because this is the solution, I am just putting W star in that, but that does not, it is equal to f of W star when alpha star equal to 0.
0.
0.
But if it is greater than 0, then this quantity has to be less
Yes.
than this quantity, right?
Yes.
I hope that is okay, right? Fine, fine.
Yes, yes.
Okay. Now what will happen to this? Can this quantity will get cancelled? Equal to 0. 0 is less than or equal to the first star G of W star. Is that okay? we just subtract, like take all the things into one side,
Yes.
and after doing that I will be able to alpha star. I can say that alpha star g of w star should be greater than or equal to 0. Let's say this is equation number 1. Fine. And what we know already, alpha star has to be equal to greater than or equal to 0. What are the constant? What is the what is the nature of g of w star? It should be less than or equal to 0, right? Because we are
Yes.
trying to minimize the problem anyway, so this is going to be less than or equal to 0. In that case, what will happen to this product? So something is greater than or equal to 0 and something is less than or equal to 0.
Negative sign.
So the product will be alpha star
Less than
g
0.
of w star has to be less than or equal to 0, right? This is positive, this is negative. This product has to be less than or equal to 0. So equation 1 is also true and equation 2 is also true when it is possible.
When both are equal to 0.
Yeah, when both are equal to 0. So alpha star and g of w star equal to 0, then only these two will hold, and this condition is called as complex
Slackness.
slackness, right? And in multiple constant, what is that? Alpha I star g of, or I can say gi
Yeah.
star equal to 0, right? Is for multiple constraints. Okay, fine. Let us try to understand now. Okay, this is fine. Okay, what is g of w star here in our problem? 1 minus
W transpose.
w transpose xi yi, right? Or w star transpose xi yi is equal to 0. This from complementary. So let's say this is CS, complementary slackness condition. Now, alpha can take which values? It can be equal to 0 or it can be,
Greater than
so alpha I
Greater
is
than
actually greater than or equal to 0, right? If alpha equal to 0, what does that mean? What is w star? W star is xy alpha, or I can say that it is summation of I equal to 1 to n xi yi alpha, right? Or alpha I. Is that correct? Correct. If alpha I equal to 0, right? What does that mean? That data point does
no
not
importance to
contribute, right?
that.
Contribute to our W star. Is it fine? What is my W star basically is? That decides the separating hyperplane, correct? Correct. So when alpha is star equal to 0 for that particular data point, because W star is a linear combination of all the data points, if my alpha is star equal to 0, that means that the data point does not contribute to W star, right? So, and then I need to see that which points actually are able to contribute to W star. Then only because alpha I star has to be greater than or equal to 0. This condition is, so for all data points where alpha equal to 0, it does not contribute. If alpha I star or alpha I star, okay, is greater than 0, then what will happen? What will happen then? If this is greater than 0, then what will be this quantity to make the right hand side equal to 0?
That is 0.
0.
That has to be 0. right? So that means 1 minus W star transpose Xi Yi equal to 0. What does it again mean? That is W star transpose Xi Yi equal to
1.
1, right? And if you remember that, let's say this is my W star, is my, what is the equation of this separating hyperplane? W star transpose X equal to 0. What will be the equation of supporting hyperplane? W star
Transpose
transpose Xi
is
Yi
equal to
equal
1.
to 1. So, and when alpha s are equal to 0, that means they contribute to W.
X
So,
is supporting vector.
yeah, so the points which are on the supporting hyperplane, they have alpha I greater than 0, right? The other points which are not on the supporting hyperplane, do they contribute to W?
Alpha is 0.
No, right? So for them, alpha is equal to 0. So now if I wanted to use this is what it is called as a support vector machine algorithm, right? And in that case, what we are saying is, if I wanted to find the W star, I should be finding out that W star, which is because which is okay, it is a summation of I equal to 1 to n alpha I xi yi. So if I wanted to find this W star, do I need all data points or I need like some data points?
The one who lies on the border.
Yeah. So we don't want like all data points. We just wanted the points which are on the supporting hyperplane.
But
Right?
not all the data points on the supporting hyperplane will be
Right. No.
support vectors.
So those data points which are on the supporting hyperplane, we only consider them only. So only these points will contribute to my
Yeah, but
W
that is
star.
not necessary, if even if the constraint is satisfied, alpha star cannot alpha star I can be greater than or equal to 0. No? I mean, when the constraint is satisfied, if alpha star I is greater than 0, then it is a supporting vector. If alpha star is equal to 0, then it is not.
So sorry, again, can you just repeat it once more?
What I'm saying is, like, all supporting vectors are on the supporting hyperplane, but not all the vectors on the supporting hyperplane are support vectors.
Yeah. So only those points which are for which alpha I star is greater than 0, right? They are
Yeah.
only the supporting hyperplanes, or they are only the support vectors. That need not be like necessary to have this.
All the
Like,
points.
yeah. I think that we are not discussing in this. I think the next week we are discussing it. But yeah, that is correct. So not all the data points which are on the supporting hyperplane should be support vectors. But right now, whatever we have observed is that the data points which are on the supporting hyperplane, they are only the points which are important to us, right? The remaining points, like these points, right? These points are definitely not for our, or we don't have
Negligible.
to care about that, right? Correct. Is that fine?
Sir, in those points where the points are lying on that hyperplane,
Uh,
their alpha is equal to 0, right?
like lying on the hyperplane, no. For them, the alpha I star equal to, it should be greater than 0, right? Alpha is equal to
Can be
0
0
is
also,
for
no?
this point.
Can be 0, then the data points are not.
No, for hard margin classifier, it is not the case. That is for soft margin classifier, basically. Not for this case. This is actually hard margin SVM. It's hard margin SVM. In this case, alpha star equal to 0 for data points which are on the supporting hyperplane. Okay.
Sir, can you go back to the complementary slackness?
Yeah.
Okay, so here, if we take the constraint to be 0, no, then then the constraint is satisfied, no? I mean, W star transpose Xi into Ya is equal to 1. That means the constraint is satisfied. Then, if the constraint is satisfied, to make this 0,
Hmm.
alpha I star can
Can be
be
greater than
greater than
0.
or equal
Right.
to 0, right? So it
Right.
is not necessarily it is always greater than 0. So all the data points on the supporting hyperplane can be greater than
Yeah.
or equal to 0. If that is
Correct. Correct.
alpha
Yeah.
star is greater than 0, then it is supporting vector. If
Right.
it
Right.
is
Right.
equal
Right.
to 0,
Right. Right. Right.
it's not
Right. Right.
strictly greater than 0.
Correct. Correct. So only those points which are for which alpha is or let's say both the constraints are satisfied, right? Uh, they should have they should be called as support vectors, right? You're right. Right. But basically, the only thing which we need to think about is the points which can be support vectors. Okay, let's see which can be support vectors. Can be support vectors. Uh, they they are lying on where?
On the supporting hyperplane.
On supporting hyperplane, right? Okay, this is okay. Yeah, fine. So and for so we know that W star is a linear combination of W. Now we can say that it is a sparse linear combination of that sparse linear combination of data points. What do you mean by that?
Like small combination.
Not not
Not
small.
everyone is contributing.
Yeah,
I mean,
Not
yeah,
everyone
there are
is contributing.
few data points. No, remaining data points
correct.
which are not on the hyperplane, we are neglecting.
Yes, yes, right. Okay. Yeah. Now one more thing is if I wanted to
Sir,
kernelize this, yeah.
sir, like we were showing a problem now. Like we
Hmm.
were doing when we were doing the W prime calculation. You'll be showing it after this.
Which one?
When we selected, we didn't select like W prime.
Yeah, yeah.
We
Okay.
select.
Yeah. W prime, right? So basically,
Uh,
so that is what like okay. Let's go there. Anyway, we are like about to finish this. Okay.
Sir, this
Uh,
week numericals are not there, or the problems will be coming from this formula itself.
yes, yes. The problems will be dependent on this formula. There will be one more formula which is for kernelized version. The problems can be from there. Numerical problems will be there. Fine. So what is the kernelized version? So if any test data point is given to you, how will you write? And if you have W star, how will you find out this answer? Or not W star? Okay, I'll finish this and then maybe I'll go back to that other point. Let's say if you have given X test, right? And in the kernelization, how will you do that? W star transpose X test will be the prediction, right? What is the prediction here? Prediction for X test, and W star is the vector which is we have learned from SVM, right? How does it will look like? What is W star here? Summation of I equal to 1 to
Alpha
n
x y.
alpha I xi yi transpose, right?
transpose, yes.
Transpose X test,
X Y X.
right? Correct. If I
So
multiply that,
earlier you have not taken transpose, but why you are taking transpose now?
this prediction, na? This is what we
Okay.
have learned. See, W star we have learned already, which is what? Summation of I equal to 1 to n xi yi, sorry, alpha I xi yi. This is during training, correct?
Yeah. Uh-huh.
We have learned it from the training data, correct?
Hmm.
Now I wanted a prediction. Prediction, how will you do that? I use W star and I take the transpose only, right? That is what my prediction will be.
Hmm.
Then that will give me what value? W star transpose X test will give me what? Y hat, right? sorry, y test, or the prediction for basically what will be my label to X test. Correct. I'm interested in the labels, right? It has what is the label for this X test, plus or minus one. What I do is I'll just take W star transpose X. I will see that which side it is lying, and whatever side it is lying, I will say that this is what the label for that W star, or that X test. Correct, right? You understand?
Okay.
Okay.
Yeah.
You understand? Otherwise, I'll write down this. This boundary we have learned from the data points which are there. So suppose these are my support vectors, right? Let's say these are all. So this is what we have learned. This W star is learned from this data. Now there is this data point is here, right? My X test. How will I decide what is the label for X test? I will use this W star. I'll take W star transpose X test, right? And what will be that line? That will be this line, or that point lies on this line, right? And this is what W star, and the equation of this line will be W star transpose X test. So I get some value because this is the scalar quantity, right? And if that is positive, what does that mean? Label for this data point is positive, right? I hope you understand this part. We are calculating the score basically. Fine.
Yes.
This for this, this is happening during test. Okay. Okay. Then what will happen then to this quantity? It will be summation of I equal to 1 to n
Why I
alpha I yi xi transpose.
why I
Why this is
also
not?
think
Yeah, why this is not alpha and yi is not transpose? This scalar, this is
no,
also scalar, right? The transpose is same, right?
right.
Right?
Yes, yes.
Right? And then it will be X test. This xi transpose and X test both are in RD. Okay. Now, what is next? This is what like during training which we do. But if I wanted to use the kernelized version, what should I do? In kernelized version, how we are going to
KX,
find out? It will be W.
KXIX tests. Kernel of X, yeah, 5x tests.
Then this will be K, right? Or not xi transpose, just xi, comma. Is
XIX
that okay?
test.
This for kernel version. This for this normal version, right? W star transpose test. Fine. I hope this is clear. Okay. I think we have. I was discussing about the other part, which was uh, why we standardize that, right? Why we standardize that condition. I'll just maybe go back to the place where we were discussing.
You actually rub that part, sir.
Okay. This one was there, huh? This figure.
I think this is after this, sir. Yes.
Here there was no doubt, right? Okay. I think we were discussing
W
how we
prime,
are
W prime. Yes,
yeah.
yes.
So this is what equation looks like, right? In general, how you compare the two things, that was I discussing that kg and pound example I have taken, right? So
So
if the
actually
units are
you
ah,
took W gamma and then you show the W prime and then you told like which W we should take.
okay, that one. Okay, fine, okay. Okay. So how is this? So we have said that gamma is a function of W and they are related to each other is this way, right? My problem is maximize this quantity, maximize this quantity such that I'll get this W, right? Till this point is fine. And I think this W star, when I'm talking about, it is W by
Gamma.
gamma, or maybe I can say that this case, or okay, I think that is okay. Let's say gamma also is fine. I'm saying that this is what the case is. When we are solving this part, if you understand it, if I wanted to maximize this, right? What does and what is the parameter here? We are trying to find out a variable W, right? So if I wanted to maximize the margin,
Minimize W.
I'll whatever what I get is the I should be choosing the minimum value of W, right? If I choose minimum value of W, then only my gamma will be higher. Is that okay?
Right.
That also is fine, right?
Yes.
And now we have taken one more constant. I think okay. Let us say this was the case gamma, and another part we were discussing is length of W square is equal to 1. These two were the conditions. Now I say that this is the space I should be looking for W's, right? This is my W1, this is my W2, right? Both of them are of what length? Length of 1. If they are of length 1, how should I say that? And so if the length is equal to 1, right? How I'm going to compare this to margins? The margins will be same or margins will be different in this case?
The same only, no, sir.
They will be same, right? Then how can I choose which is the better W? That is not possible, right? Then
Hmm. Yeah.
that's why what we are doing is whatever the gamma is there, or okay. So okay. So what do I was okay. I forgot. Okay. I just wanted to
I'll
explain
tell
you.
you the points, sir. I'll tell you the points.
Ah,
Sir, you took W1 equal to 10,
hmm.
norm
Okay.
of W.
Yeah, that is okay. Anyway, that is cooked up example. You just
Yes.
tell me what where you didn't understand this part, like effective W's part.
Yeah, because after like computing the norm, right? Say for
Ah,
example,
ah,
sorry, the W1 prime, W2 prime, and W3 prime. So
hmm.
we went ahead with W2 prime, which was the highest,
Okay.
which was W
Okay.
by gamma basically.
Okay.
So that part basically. Right? So I hope you can get me right, sir.
Yeah, I understand, but I don't know like how to explain that part to you.
Okay.
Okay, so let's say for success part is more you or just give me 2 minutes. I'll just think about it. This one need to do that. Okay, fine. So here how to make, so okay, I just wanted, so these two constants are there for me, right? 1 and 2, correct? Right? If I wanted to merge these two conditions, how will I do that? So I wanted the length should be equal to 1. So this W can be anything, right? So W1 can, this W1 is correct. Is this W1 correct? All this, let's say this 2W1, this is 3W1, something like that. And similarly, we have this W2. Then I have, let's say 2W2, or I have 5W2 like that, right? All this can be possible W's because we are not saying anything about this W. But if I wanted to say that this constant is there, so length of W square equal to 1. If I wanted to make that, the simple thing to do is that if I just divide it by that margin, right? So I think I'll make that length as equal to 1, right? So okay, let me, maybe I'll if I just recollect all the things, right, I'll tell you about that. But the importance of this part to make this margin as equal to 1 is only that to standardize the things. Okay, the standardization is required. What do you mean by standardization anyway? So the basic crux of that is to make this units as same, right?
Right.
Correct.
So we will be able to compare the different values of gamma. Like for example, I should be able to compare the kgs with the pounds,
Hmm.
right? So that was the that was actual, not like this. That was the actual crux of it. Why we wanted to divide it by gamma. How to choose it? Like maybe at some other point I'll discuss that with you. Right now I'm not able to explain it to you properly. But the important point over there is why I should be able to divide that gamma is so that I can compare different W's which with each other. That was the case. Okay. Maybe I would
Yes,
have
yes, that was the
some,
case.
yeah, that was the case. Maybe I mistaken while explaining to you. But yeah, if ever whenever I recollect it back, I'll explain to you properly again. Fine. Right. Support vector machine. Do you understand the support vector machine and the kernelized part of that?
Yes,
Right.
yes.
Yeah. But while we develop an algorithm for support vector, what was the condition or what were the constraints? Assumptions we have taken that the points are
Linearly
linear
separate.
separable, right? That means all data points should be correctly classified, right? Right? That was the assumption we have made. This was the assumption while we start with the hard margin SVM. But in real world, this is possible? No, right? There will be certain points which may not be in a training set. They should not be, or they are not actually correctly classified. In that case, or let's say this is the case, if your data set is like this, so what these points are doing? They are not correctly classified, right? So this will not work with the hard margin classifier, and we consider these points as, or what we are saying to this point as outliers. Okay, right. So we should be able to do something with these points. Uh, in that case, what we do is we this point should be where, if this is positive class, or is this a positive class or negative class? This is negative class right now, right? Or this is positive class, but uh, if it is a positive point, where it should be lying?
On the right side.
Right. Let's say it's called these are all called as the outliers. Fine. Outlier has to go to this side, and this also has to go to that side, so that if that will happen, what then all the data points will be able to correctly classified. But when that will happen and how that will be happening, I should be able to move those points to their respective sides, right? And that will be done by using the modified formulation, which is called as a short margin formulation. And what is that? What was your hard margin objective? It was the minimizing half W square, right? And the constants were the stat W transpose. Constants are W transpose xi yi greater than or equal to 1, right? That was the constant. Now with this soft margin, what we are doing is we are paying some bribe. Bribe means they're just adding certain value so that this positive point goes to their respective place, right? So to the respective side is the positive side, and this negative point will come to the negative side. And we'll say that it is sum I equal to 1 to n. Okay. This is what the hyperparameter is. The hyperparameter. What is the or which parameter is called hyperparameter?
The bribe.
No, this C is a
See,
hyperparameter. In general, hyperparameters are the parameters which are defined by us, right? They are not the inherent parameters of the like formulation. For example, here W is a parameter, right? W is a parameter which is there in the formulation, which can be determined using the training data set or with the data points. C is the hyperparameter. How we should be finding out these hyperparameters? By cross validation technique, right? I think we have seen that that kind of parameter previously. What was that parameter in the previous week? It was lambda, right? Regularization parameter. Like that, C is a hyperparameter, and that has to be found out by cross validation technique. Fine. And this formulation will become plus 1 and 0 for all I. Do you understand this point? Look like. Is that okay? What we are doing is we are paying certain bribe. That means we are uh, and why it is greater than or equal to 0 for all those points which are correctly classified. What is the value of epsilon I for correctly classified points? What is epsilon I? It has to be equal to 0, right? And for correctly classified points, or we are calling them in this case, in this uh, course, as outliers. For them, the epsilon I will be greater than 0, right? This is what, okay, I'll just write down again one more time. Is hard margin formulation, hard margin primal formulation, soft margin formulation. What is hard margin primary formulation? It is minimize over W half of W square such that W star transpose, it's not W star, W transpose xi yi is greater than equal to 1. Soft margin formulation is minimize over W epsilon half square plus C summation of I equal to 1 to n epsilon I such that W transpose xi yi plus epsilon I equal to 1 is for all I. Is that fine? This is applicable to all data sets. Applicable. This is applicable to only linearly separable data sets. Is it okay? Fine. Okay, are you guys there? Okay, fine. Okay. So I think this is it from this week. We are out of time right now. So what I'll do is I'll solve the slide side. I'll share that with you. You can see those questions, and then I'll share this PDF also with all of you. I'll not upload maybe on the portal, or if you want, I'll upload it on the portal as well. But basically, what I'll do is I'll just add this slides right to the calendar. Okay, along with the solve with the slides also.
So can we have a
Huh.
request for a solve with a session next week for this one?
For this,
If it's possible, not today.
yeah, if you want, I can arrange that one. That is okay.
Obviously, like other students will also need to have time.
Fine, fine. So no, I think the deadline is today, right, for week 10, or is it?
Yeah,
not?
it's today, but I'm just asking for the solve with a session.
Yeah, if you want, I'll have.
Yeah, that would
maybe.
be better actually. Sir.
Yeah, I can have you. Maybe you can message me. I'll just. I think you can message me. We'll arrange that one. That's okay.
Yeah.
Okay.
Solve with a session, right? Yeah.
Solve with us with the instructor if you want, or if you want with TA, both we can arrange. Whatever is
Anyone,
fine.
so that is totally up to you.
Huh?
Yeah. One session, solve with a session is if
Yeah.
it's
Okay.
done, yeah, it is good.
Yeah, sure. Again, but still, I'll add these slides on the portal. You can watch those slides. Right.
Next week probably you can arrange one. Sir. Come
Yeah,
in this.
like maybe this week only we'll arrange. Not
Yeah, this week. Sorry.
Okay, fine. Okay, guys. Okay. I hope you the concepts are clear. Maybe you again. I think I'll have to watch the lectures one more time so that.
I think, sir, with solve with us, it will become more clear.
Yeah, then the numericals will be clear and all things will.
Yeah,
whatever we have learned, maybe we'll be able to connect all the things. That
maybe
is true.
Monday or Tuesday, if possible, you can see.
Sure.
Yeah, I think you should pair this with or solve it with a suggestion.
Yeah, okay, fine. Yeah, but see, sometimes what happens is this theory, whatever is there, right? The students are not able to, understand. First of all, linear algebra perspective, right? And if I just directly take the solve with us, sometimes see, this was 2 hours lecture and basically 2 hours lectures in the recorded videos, right? But we took like around 4 hours to explain it. That was the case. But
No,
fine.
but it's a combination of linear algebra and coordinate geometry. So
Coordinate
those
geometry, right.
concepts and teach it will be easy.
Yeah, okay. Then we'll have one session.
Yeah, solve with us, right?
Yes.
For week
Fine.
10.
Yeah.
Because these are all real life things actually.
Correct. Right.
Very, very
And one more.
actually.
Right. This is important algorithm anyway. So we will have that one. Okay.
Yeah, once also, sir, if we do the problems, then a lot of things gets cleared also.
Sure. let me see if I can be able to conduct. I will do that, or else
Yeah.
Srinivasan will do that. Okay,
Okay.
fine. Okay, okay. Thank you guys for staying back.
Thank
Yeah,
you.
thanks.
Thank you, sir.
Thank you.
Thank you. Thank you.